Okay, picture this. It's 10 p.m. on a Friday. You've been grinding all week on a critical feature, and it's finally time. Time to push it to production. So you take a deep breath, you run the deployment script, which, let's be honest, is probably just you manually copying some files over to the server, and you hit refresh on the website. And there it is. A blank white screen, a server error, deployment failed. Your heart just sinks, right? And now it begins, that frantic scramble, digging through logs, trying to figure out what on earth went wrong, all while your phone starts buzzing with alerts from the monitoring systems. Look, we've all been there. It is a stressful, broken process that has haunted software development for years, and it's the exact problem we are going to solve today.
You know, this whole chaos, this late-night anxiety, it really all boils down to a few core problems that you see everywhere in manual setups. First, you've got the classic developer excuse, but it works on my machine. And the most frustrating part, they're probably right. It does work on their machine. But the production server? It has a slightly different version of a library or maybe a different operating system patch level. These tiny, almost invisible differences between environments create these nasty bugs that only show their face after you've deployed. Then there's the bigger problem of inconsistent environments themselves. Your development machine, the staging server, and the production server, over time, they've all drifted apart. They're kind of like estranged siblings who don't even look alike anymore. And when something inevitably breaks, who do you blame? With manual deployments, there's almost never an audit trail. You have no idea who deployed what or when they did it, which just makes debugging a complete nightmare of finger pointing. It is just a high-stress, error-prone mess of moving files and crossing your fingers.
So let's really walk through this manual process, because to understand the solution, you have to feel the pain. It usually looks something like this. First, you finish your code on your laptop. Great. Then you manually zip up the project files, and you get that nagging feeling in the back of your head. Did I forget a config file? Did I actually include the latest changes? You open up a terminal, you SSH into the production server, then you have to upload that zip file, unzip it, and very carefully copy the new files into the right directory, overriding the old ones. Finally, you restart the web server and you just hope. Every single one of these steps is a landmine, a place where a simple human error, a typo, a forgotten file can bring the entire system crashing down.
Look, this manual, anxiety-inducing process is just not sustainable. It doesn't scale, it's not reliable, and frankly, it is a terrible way to build modern software. There has to be a better way, and that better way is built on a simple but incredibly powerful philosophy: automation. We need to take the error-prone human out of the loop as much as possible.
So the first piece of this philosophy is something called continuous integration, or CI for short. Now this isn't just a tool, it's a whole development practice. The idea is really simple. As soon as a developer commits a piece of code to a shared repository, an automated system immediately grabs it, builds the entire application from scratch, and runs a whole suite of automated tests. The goal here is to get feedback, and to get it fast. If you just introduced a bug, you want to know about it in minutes, not days later when you're trying to merge a month's worth of work with your team. CI is what prevents what we used to call integration hell.
The second piece of the puzzle is continuous deployment, or CD. And this really just takes CI to its logical conclusion. Think about it. If a code change passes all of the automated build steps and all of the test steps, why should it sit around waiting for a human to manually deploy it weeks later? It shouldn't. Continuous deployment is an automated process that takes that validated code and releases it directly to your users. Every single change that passes the tests goes live, automatically. This is absolutely revolutionary because it lets teams deliver value to customers incredibly quickly and get rapid feedback on new features, shortening that loop from idea to reality.
And when you put these two concepts together, continuous integration and continuous deployment, you get what we call a CI/CD pipeline. You should really think of it as the modern assembly line for software. It's a completely automated workflow that takes your code from a single commit in a repository, guides it through building, testing, and finally deploying it to production, all without any manual intervention. This pipeline is the direct, concrete solution to that chaotic Friday night deployment we started with.
But okay, that all sounds great in theory, right? A magical assembly line for your code. But how do you actually build it? What's the engine that powers this whole automated pipeline? What tool is actually orchestrating this entire process, watching your code and kicking off all these steps one by one?
Well, meet Jenkins. If your CI/CD pipeline is the assembly line, then Jenkins is the tireless, open-source automation butler who runs the whole thing. For well over a decade, Jenkins has been the go-to server for automating just about anything you can think of. It really exists to do one thing and do it well: automate all the repetitive tasks involved in building, testing, and deploying software so that developers can focus on what they do best: writing great code.
So what does our automation butler actually do all day? Well, it connects directly to your code repository, something like GitHub or GitLab. When it sees a new change, a new commit, it automatically builds your software. Then it runs all of your automated tests to make sure that new change didn't break anything. And if everything passes, it can deploy the application to your servers. In short, it automates that entire CI/CD pipeline we just talked about from the very beginning to the very end.
Now here's where things get really interesting, and how Jenkins is designed to scale way beyond just a simple project. It uses a simple but incredibly powerful architecture, the controller and its agents. You can think of it like a brain and its many, many hands. Understanding this concept is absolutely key to understanding how Jenkins works in the real world.
The Jenkins controller is the brain of the whole operation. It hosts the web interface where you configure everything, it knows about all the jobs and pipelines you've created, and its main role is to schedule and assign work. But, and this is crucial, the controller itself really shouldn't be doing the heavy lifting. For that, it uses agents. Agents are the workers. They are totally separate machines. They could be physical servers, virtual machines, or even Docker containers that connect to the controller, wait for instructions, and then execute the actual tasks. The builds, the tests, the deployments. This separation of concerns is the secret to a scalable and resilient automation setup.
And this right here illustrates the real-world power of this model perfectly. Imagine your application needs to run on both Windows and Linux. Well, you can't compile and test both of those on the same machine. With Jenkins, that's not a problem at all. You simply set up a Windows agent and a Linux agent. The controller is smart enough to know which job needs to run where, and it'll send the Windows build to the Windows agent and the Linux build to the Linux agent. This is how you can scale your build capacity and handle all sorts of diverse environments without ever overloading a single machine. It's a game changer.
So in the Jenkins world, any task you want to automate, whether it's building a complex app or just running a simple script, is called a job. And for a very long time, the main way to create a job was with what's called a freestyle project. This is the classic, original way of working with Jenkins, and it's how many of us, myself included, first learned the tool.
Freestyle projects are configured entirely through the Jenkins web interface. You get this big page full of drop-down menus and text boxes, and you just point and click to configure everything. Where your code is, what commands to run, what to do after the build is done. It's actually very easy to get started with, which makes it great for simple tasks or when you're just learning. But this point-and-click approach is often called ClickOps, and as we're about to see, it has some really serious drawbacks in a professional environment.
So what happens when your simple little job grows into a complex 50-step deployment process? How do you keep track of changes to that process? If someone on your team breaks the build job by clicking the wrong thing, how do you review their changes or roll them back? With Freestyle projects, you can't. The entire configuration lives only inside the Jenkins UI, totally disconnected from your code. If your Jenkins server dies and you don't have a backup, that entire configuration is just gone forever. You have to try and rebuild it from memory. This exact problem, this nightmare scenario, is what led to the development of the modern standard for automation in Jenkins, pipeline as code. The philosophy here is simple, but it is profound. Your build, test, and deployment process is a critical part of your application. Therefore, it should be treated just like code. It needs to be versioned, reviewed, and stored right alongside your application's source code in your repository.
And that's the crucial point. With pipeline as code, the Jenkins file becomes the single source of truth for your entire pipeline. It's no longer some mysterious configuration hidden away in a web UI that only one person understands. It's a plain text file that anyone on the team can open, read, and understand. Changes to the pipeline can be made through pull requests, just like any other code change, which fosters collaboration and gives you a crystal clear audit trail.
And that brings us to the beating heart of modern Jenkins. A Jenkins file is quite simply a text file. It's literally named Jenkinsfile, and you place it in the root of your project's repository. This single file contains the complete definition of your CI/CD pipeline written in a specific syntax. When Jenkins scans your repository and finds this file, it automatically reads it and executes the pipeline you've defined inside. It's as simple as that. By the way, if you're enjoying this deep dive, consider liking this explainer and subscribing for more DevOps and infrastructure content. It really helps out.
Okay, theory is great, but let's make this real. We're going to walk through a complete Jenkins file for a simple Node.js web application, step by step. The syntax is based on a language called Groovy, but don't let that scare you. It's a specific, simplified version of Groovy designed to be very readable. You absolutely do not need to be a programmer to understand what's going on here.
So every modern declarative Jenkins file starts with this: pipeline inside curly braces, parentheses. This is the main block, the wrapper that encloses the entire pipeline definition. Everything else we're about to look at will live inside these curly braces. It's the first thing you write, and it tells Jenkins, hey, what follows is a structured, declarative pipeline.
Next up is the agent directive. This is critical. It tells Jenkins where to actually run the pipeline. Agent any is the simplest option you can use. It just means, hey Jenkins, find any available worker agent you have connected and run this job there. I don't care which one. In more advanced setups, you could get really specific here, maybe specifying a particular type of agent, like one that has Docker installed, using labels like agent label Docker host.
Okay, now we get to the core of the workflow, the stages block. A pipeline is really just composed of a series of distinct stages. You can think of these as the columns on that factory assembly line we talked about. Each stage represents a logical part of your process. And these are not just for organization, they're visualized beautifully in the Jenkins UI, so you can see exactly where your build is in the process, and more importantly, exactly where it failed if something goes wrong.
Our very first stage is almost always going to be checkout. Inside each stage, we have a steps block which contains the actual commands we want to run. The command here, checkout SCM, is a special built-in Jenkins step. It's a shortcut that tells Jenkins to check out the source code from the source control management system, like Git, that triggered this pipeline run in the first place. This is how we get our code onto the agent so we can start working with it.
Next, we move on to the build stage. For our simple Node.js application, the build step is really just to install all of its dependencies. The sh step is another common one. It simply means execute a shell command. So here we're just running npm install. This command reads our project's package.json file and downloads all the necessary libraries from the internet. This is a critical step for creating a repeatable environment for our application, ensuring every single build runs with the exact same dependencies.
Now for what is arguably the most important stage, test. Here we run npm test to execute our suite of automated tests. This stage acts as a quality gate. If even a single test fails, Jenkins will immediately stop the pipeline right here and mark the entire build as a failure. This is the fail fast principle in action. We find the problem instantly, we notify the developer who broke it, and we prevent that broken code from ever moving further down the pipeline toward production.
And finally, if and only if all the previous stages have passed with flying colors, we reach the deploy stage. Now in this example, we're just using a simple echo command to simulate a deployment. But in a real-world pipeline, this steps block would contain the scripts to maybe copy files to a web server, or build a Docker image and push it to a registry, or maybe apply new configurations to a Kubernetes cluster. This is that final step that delivers our validated, tested code to our users. So we've just walked through a full pipeline that's defined entirely in code. But let's take a step back and ask the really critical question. Why is this so much better than the old way of just clicking around in the Jenkins UI? What do we actually gain from all this effort?
The benefits are just massive. First, your pipeline is now completely repeatable. Anyone on the team can check out the code and run the exact same process. It's under version control, which means you have a full history of every single change ever made to your deployment process. You have a real audit trail. You can use a command like git blame to see exactly who changed the deploy script and why they did it. It enables true collaboration, allowing developers to improve the pipeline through pull requests, just like any other piece of code. And maybe most importantly, you get disaster recovery built in. If your Jenkins server gets destroyed, you can stand up a new one, point it at your Git repository, and all of your pipelines are instantly restored. This is something you simply cannot do with Freestyle Jobs.
Okay, so let's get real for a minute. Jenkins is incredibly powerful, and it has been the cornerstone of DevOps automation for over a decade. It is a fantastic tool, but it's really important to be realistic. It's not a magic bullet, and in the real world, it definitely comes with its own set of challenges.
So Jenkins' greatest strength is its incredible flexibility. With over 1,000 plugins, it can integrate with virtually any tool you can possibly imagine. It's open source, it's free, and it has a massive community behind it. However, that flexibility is also its greatest weakness. It has a pretty high maintenance overhead. You are responsible for the server, the Java version, the updates, and all those plugins. This can easily lead to what we call plugin hell. The learning curve can be steep, especially with more complex pipelines, and let's be honest, the UI feels a bit dated compared to more modern integrated tools.
Here's a classic real-world scenario that you will absolutely hit, I promise. You'll see that little notification in the UI to update a plugin, you'll click Update thinking you're being a good administrator, and then suddenly, half of your pipelines start failing with the most cryptic errors. You have just entered plugin hell. And you might spend the rest of your day figuring out that the new version of the Git plugin is incompatible with an older credentials plugin that everything else relies on. Managing this vast plugin ecosystem is a huge part of being a Jenkins administrator.
So let's just recap our journey here. We started in a world of total manual chaos, with stressful late-night deployments and that constant fear of breaking things. We then moved through the core philosophy of CI/CD, and finally, we used Jenkins and the power of the Jenkinsfile to build an automated, reliable, and version-controlled pipeline that directly solves those initial, painful problems. If you walk away with anything, it should be these 4 things. First, automation is the key to preventing manual errors and building reliable software at scale. Second, CI/CD is the practice that gives your team that fast feedback, allowing you to move quickly and safely. Third, Jenkins is the powerful open-source engine that can orchestrate your entire automation workflow. And finally, the Jenkinsfile is the modern standard bringing the power of pipeline as code to your projects, making your entire delivery process transparent, versioned, and resilient.
So the final question is Jenkins the right automation orchestrator for your next project? Well, while newer, more integrated tools like GitHub Actions and GitLab CI have definitely emerged and are fantastic options, understanding Jenkins is still fundamental. It really pioneered many of the concepts that are now standard across the entire world of DevOps. So whether you choose to use it or one of its successors, the principles of automation, of CI/CD, and of pipeline as code that Jenkins championed for so long will remain absolutely essential to building and delivering great software. If you found this helpful, make sure to like the video and subscribe to DevOps Corner for more deep dives like this.